Okay. I'm about to teach you something which is a bit complicated, not only to understand, but also a bit complicated to teach. So I'm just going to move at a slower pace, but trust me when I say everything that I'm going to explain, you will definitely understand. So the best tip that I can give to you is to say, try to redo the exact same examples that I'm going to be doing. Redo them as many times as you can before you attempt the short test for today. So I'm going to start off with what I regard as an easy part, and then I will let you know when I get to the complicated part. So just to avoid giving you too much of information which may end up confusing you, I will just limit it to what I figured out, or I will limit it to the strategies that I used to apply. So remember, I'm talking about a function value of a negative angle. So, in other words, you may be given, let's say, sine of whatever angle, and that whatever angle, let's say, it is a negative angle. Not only that, but as you know, we still have this trig ratio being cos. That means you may be given cos of whatever negative angle. So I'll just use theta there. But what matters the most is that it just has to be a negative angle. So what is this equivalent to? What is this equivalent to? What is this equivalent to? What I've discovered is very simple, and of course I've discovered this after days and days and days of practicing. What I've just discovered is that actually, if you have a sine of a positive angle, cos of a positive angle, tan of a positive angle, you are just having an angle which is rising in an anti-clockwise direction. So that will be a positive angle. But when you are having a negative angle, then it is actually an angle in a clockwise direction. So my conclusion was that every negative angle that I'm given, I will assume it to be falling in the fourth quadrant. It doesn't matter whether it's a bigger number, it's an angle that is being added to something. As long as it is sine, cos, or tan into a negative angle, it will always fall in the fourth quadrant. What does it mean? Just don't get confused by these lines. Remember, it is a negative angle in there. Let me just remove it so that I am 100% sure that it doesn't form confusion. Okay, so what I said was sine negative angle, cos negative angle, tan negative angle. I said it is an angle in the clockwise direction. So we will just always assume it to be falling in the fourth quadrant. So now it becomes easier for us to give the answers to sine into negative angle. In which quadrant does that fall? Obviously, because it's negative, then it falls in the fourth quadrant. In the fourth quadrant is sine, negative or positive. We remember the cast diagram. In the fourth quadrant, sine, it is negative. Therefore, this is negative sine of an angle. What about cos? Cos in the fourth quadrant is positive. Therefore, this is positive cos of an angle. What about tan? Tan in the fourth quadrant is negative. Therefore, this is negative tan of an angle. So now you have this important information that you will use many times in this topic. But for now, just be aware of that. Trust me when I say I've gone through textbooks where you can go for like 2 full pages trying to understand all of this. But at the end of the day, it all comes back to what I've just explained now, to say When you're given a negative angle, assume it to be falling in the fourth quadrant and then interpret it just like I've taught you with the others. Don't confuse it with the 180 minus 360 minus 180 minus 90 minus. We don't have those here. It is just a negative angle. So that's why I'm saying it falls in the fourth quadrant and you easily interpret it. So that one of changing and all of that, that's if we talk about the 90 and 270. So here you can see I don't have 90, I don't have 270, I don't have 180, I don't have 360. It's just tan, cos, sine of a negative angle. That's all that you needed to be as the first easy part. Now let's talk about the difficult part that I was referring to. But definitely you will understand. So now this is function values of theta plus k that is being multiplied by 360 degrees. You will understand it, don't worry that much. Okay, so this is what happens, honorable member. For example, you may be given angles which are bigger than 360 degrees. So that's what we are going to be dealing with here, and those bigger angles we will just rewrite them in this format of theta plus k multiplying that, where this theta, it is that acute angle, the reduced angle. Remember, what we are trying to achieve is to end up in a situation where we are given cos, tan or sine of a bigger angle and we want to reduce it to acute angle. On our previous lesson, we looked at angles which were between 0 and 360. So now we are going to be looking at angles which are bigger than 360 degrees. So that's how you would connect the dots. So let's maybe interpret these angles. Let's say an angle bigger than that, let's say 400 and that. Another angle that we can look at, maybe let's look at 770. And the last angle that we'll, let's just be fair and give us a tricky situation where we give us a negative angle there of that. Okay. So how you interpret this, honorable member, you just need to be aware that let's start with this one. On a Cartesian plane, on a Cartesian plane, you obviously know that this rounds by 360 degrees. But the moment we are given an angle which is bigger than 360 degrees, then it means it will continue to make that circle from 0 all the way up to 360 degrees. We looked at the angles which were between those. Now we are looking at an angle that goes beyond 360 degrees. So that means it is actually 360 plus. So 410, it is the same as 360 plus 50. I hope that part makes sense. So it is 360 plus an extra of 50 degrees. So how do we interpret this by that function value of that? Look at how easy this should be. It means we are actually, maybe let me rewrite it like this and say, it is that extra acute angle that we have to plus it by how many 360s. Did you hear what I said? It has to be that acute angle that we plus it by how many 360s. So obviously that has to be equals to that 410 degrees. So it's like we are saying 410 degrees it is the same as 50 degrees that we plus it by 1 of 360 degrees. And this is the one which is equals to 410. So can you see, we have just represented it in that format. Let's maybe look at another one. So it's like I'm saying, if you punch 50 and then you plus it by 1 times 360 degrees, it will give you that. It's like we have a number which is more than 360 degrees, and we just try to rewrite it in that format. But also, remember, it doesn't mean this will always be an acute angle. It can be whatever angle. As long as that angle is less than 360 degrees, then we will say plus how many times did it pass 360 degrees when we were doing those circles. Maybe let's look at another one, maybe that one of 770. Yes, that one of 770. Let's see, 770, it will be the first 360 degrees. Let's see, 770, you can just say minus 360. We know we have the first 360. Then you can minus again by 360. Yes, it does the second 360. And then what remains is 50. Then it means it ends there. So this one of 770 degrees, because it was a positive angle, you would realize that I was swinging it in that direction. So that one, it doesn't really matter that much. So that means in this case, you will easily say, actually, to rewrite it in that function value of angle plus k times 360, we will say 770 is the same as 50 degrees that we plus it by how many 360s did we swing? We swinged 2 times 360 degrees. So this is what gives us that 770. So can you see, we just had to represent this 770 in that format. Very, very much important in that format to say 770, it is made of 50 plus 2 of 360 degrees. It will always be in that format where you say an angle plus whatever times of 360 degrees, because we are looking at an angle which is bigger than 360 degrees. That's why that part. Okay, luckily I am back. So I tried to actually slide something there, and then it actually took me out of this. Luckily I had an option to resume. Okay, then it's fine. I think I did explain what I had to explain there. Let's look at this one of a negative angle but still being bigger than 360. Maybe this one of negative 670 degrees. That negative, it should just not worry you that much. That negative 60 is just you, instead of swinging in that direction, you swing in the opposite direction. That's all. So that negative simply means you have full 360 and then you need to add an extra. So that means, let's see, 670 minus the first 360, you remain with 310. So you see now that 310 it's less than 360. So whatever that remains, as long as it is 360, then you are done. So it therefore means what does it mean exactly? Wait. Just want to confirm there that 670 years. Let's see. 670 and gives that. Of which you say that, it takes you back to that. And then obviously with that, okay, then it's fine. I just realized something. I'm curious to know in terms of how best I can explain this one such that it just doesn't make any confusions. Okay, then it's fine. Maybe let me explain it this way. Do you say in this case where you are having negative negative 670 degrees, you will therefore say I'm definitely going to have an angle, of which that angle I will need to plus it by whatever times the 360 degrees. So what will that be? It will definitely be, so you are having 600 and not that but negative 670 degrees, where you have to now reduce that negative 670 degrees. So you plus it by 360 and then it gives you negative 310. You don't want a negative. You plus it again by 360 until it gives you 50 or a positive angle. Therefore, it means it becomes 50 degrees that we plus it. Obviously, this one, it was swinging in the negative direction. That's why you are having negative 2 of the 360s there, of which this is the one that will be equals to that negative 670 degrees. Out of these two, it is actually this one which is a bit complicated to understand, not only to teach but also to understand on your side. So just worry not at this stage. Do not worry that much about that at all. And also, even what I've explained there, do not worry that much. Do not worry that much. It was just for you to be aware that you may be given an angle which is bigger than that, and there are definitely going to be some ways in which you might need to deal with the problems that you'll be given. So let's try to do some examples and see how you would have to work out those examples. Not that much complicated. Let's see. Let's say number one, we are given let's say sine of 360 degrees that we plus it by that theta there. And most importantly, what they want us to do, it is to just rewrite this as a function value of theta. So it's like we do not want to have a bigger angle or anything of that nature. We want to remove everything and write it in a form of theta. If it's beta, beta, alpha, if it's alpha, whatever. So that means we need to remove that 360 degrees. So here where we have 360 degrees plus, we always assume it to fall in the first quadrant. Just like when I said, if it is either sine, cos, or tan, as long as it's a negative, we assume it to fall in the fourth quadrant. This one of 360 plus, let's always assume it to fall in the first quadrant. So, for that reason, we will therefore say, if it falls in the first quadrant, it means in the first quadrant sign is what is positive. Therefore, this is the same as positive sign of an angle. And that should be the end of it. Okay, so now let's look at another example. And on this example, let's say we are given cos of 540 degrees that we need to plus it by. Let's use beta in this case. So let's see, for us to rewrite it in that format, we will still remain with our cos, but this thing we might need to rewrite it differently. How can we rewrite it? Let's see. Because it is bigger than 360, just say 540 minus 360. Whatever that remains, it's a perfect remainder. We are given 540 that we need to break it down. And when we break it down, it ends up being 360 degrees plus 180 degrees. Remember, you still have that angle beta there. So can you see, based on what I've explained, I said the moment we have 360 plus, what do? We assume it to be falling in the first quadrant. Then it means if it falls in the first quadrant, it is the whole of this angle that falls in the first quadrant, because it is 360 plus whatever that it is. So in the first quadrant, cos is what? Cos is positive. That's why we will therefore say this thing is the same as cos of 180 degrees plus that angle. And then for this reason, I don't have space, I'll continue there. So for that reason, you see now, it takes us back to what I've taught you in few lessons which have already passed. I just can't remember what lesson number that was. But where you have cos 180 plus, which quadrant? 180 plus is this one, and here is tan is positive. So that means here it falls in quadrant number 3. In quadrant number 3, cos is negative. Then you end up having negative cos of an angle. So can you see? Now it means you are done. So let's see, what else can we do? Do we have enough space? I'll just try to force something here. Okay, let's say we have tan, and that tan, let's say we have theta there, and let's say minus, we can just say maybe minus 180 degrees there. Yes, so you will be given some things which come in a tricky way. You will definitely be given some things which are being presented to you in a tricky way, where you are used to having 180 that side and then that there. But in this case, why not rewrite it in a smart way, where you actually say, I will just take out that negative there, so that I write it in the manner in which I know I'm going to deal with it decisively. I'm not sure if you would agree with me to say what I've done there, it was to just rewrite this thing in that format, whereby if you take it back and say this times that takes you back to that negative 180. that times that, it doesn't take you back there. That means you need to edit this sign, and that sign, it therefore has to be negative. Can you see how tricky things can be and how smart you need to be? So that means the sign there has to be negative, so that when you try to take it back, it takes you back there. So it therefore means now it's like you are having tan into negative angle. Tan into negative, in which quadrant does that fall? It falls in the fourth quadrant. Just think of it as you having tan into negative into whatever angle. So what I explained was to say tan into negative angle, let's assume it to fall in the fourth quadrant, where in the fourth quadrant tan is negative. So that means we end up having negative tan into that 180 degrees minus an angle. Can you see? Things are becoming interesting now. So now you look at this, you say 180 minus, 180 minus, is it 180 minus? Wait, did I do things correctly there? Let me just quickly verify. That times that times that. Yes, I've done things correctly there. Okay, so I'm going to say 180 minus falls in which quadrant? In the second quadrant. In the second quadrant is tan positive for negative, tan is negative. So that means I have this negative that I already have, and again I'm going to have negative tan of an angle, of which that negative times that negative, then it ends up being positive tan of an angle. Then that is the end of it. The nice thing about this is that you can try to prove if it is correct where you punch it on a calculator. Let's say tan into I will use 30 and minus it by 180. I'm getting positive 0.577 and then again if I say tan 30, same thing. So can you see it does prove that I've done everything correctly. Maybe let's try do one more example. I'm just curious to know if I've got enough space. I will just utilize that part. Okay, let's say here we are given sine of, let's say this time around negative and that, and then again we say negative that. A very tricky one, but trust me when I say it's all about you being manipulative and say, actually, can I just not rewrite this thing as something like, maybe let's write it as something like, if we take out the negative there, then here it means we will need to have positive theta and again positive 90 degrees there. Yes, because if you say this times that, it has to be negative, this times that, it has to be negative. So that means you've manipulated it correctly. Most importantly, again, it is the same as sine into a negative angle there. Just interpret it that way. And what did I say? If you have a negative angle, I said if you have a negative angle, we assume it to fall in the fourth quadrant, in quadrant number 4, whereby it's cos which is positive. So that means this one is the same as negative sine of theta plus 90 degrees. This theta plus, we are used to having 90, so let me just rewrite it nicely there and just say 90 degrees being a positive 90, again plus being a positive that. So what I've just done there, it's like you having 2 plus 4, you rewrite it as 4 plus 2. That's what I've just done. So now it is easy, because I will therefore say 90 plus falls in which quadrant? Is quadrant number 2, whereby it is sign which is positive in that quadrant. So yes, it is sign which is positive. Therefore you will change that sign to a cos, because it is the 90 there. So you have that negative. You see that negative that you already have. Then you just change it to cos of an angle, and that is the end of it. Very tricky questions there, trust me on that one. So can you see, I've worked out those problems without having to think much or apply much about that. I just had to take you through that, just in case if your teacher somehow brings it up, at least you will have a background as to what the angles being bigger than 360 do, or what they are all about. But otherwise, in terms of solving the problems, you might need to apply a complete different approach. So just in case if what I've explained there, especially the part where I was solving these problems, just in case if you find it a bit difficult, try to watch this again, and then if necessary you might explore other options of booking a special lesson, or maybe somehow try to join the Zoom so that I will re-explain the parts that you may not be understanding. So not that much complicated, just trust me on that one. Not that much complicated, but definitely they are doable. I think if you try some your short test, see how far you can go. If you fail, then it's an indication that you need help on this, and then I will explain further. Yes, maybe let me just leave it here so that we do part by part. Okay, until we meet again.